Good morning, everyone. I am Dhruti from Venkateshwara College of Engineering, Bengaluru. I will give you a small presentation on image enhancement. Let's move to the introduction. Introduction. Image enhancement in digital image processing refers to the process of improving the quality and visual appearance of an digital image. The goal of image enhancement is to make an image more suitable for human perception or for computer analysis. It involves various techniques that modify the pixels in an image to highlight certain features or improve its overall quality. Image enhancement is a crucial step in digital image processing that involves improving the visual quality of an image. It aims to highlight important features of the image and remove any unwanted noise or artifacts. The process of image enhancement can be done using various techniques such as contrast stretching, histogram equalization, spatial filtering, and frequency domain filtering. These are the methods which we can improve the image enhancement. Let's see contrast stretching. Contrast stretching. So it is one of the method of the image enhancement. Contrast stretching, also known as constant enhancement, is a popular image enhancement technique which is used in digital image processing to improve the visual quality of an image. It is a spatial domain technique that involves manipulating the intensity values of an image to increase the contrast between the brightest and the darkest areas of the image. Contrast stretching is a technique used to improve the contrast of an image by expanding the range of pixel values. This is achieved by mapping the minimum and maximum pixel values of the original image to the desired output range. This technique is particularly useful in images where the contrast is low or where certain features are difficult to distinguish due to poor lighting conditions. The contrast stretching technique can be performed using two different methods. One is linear and other is non-linear. Linear contrast stretching involves scaling the pixel values linearly so that the minimum and the maximum intensity values in the image are mapped to the lowest and highest intensities available. Nonlinear contrast stretching involves using a more complex transformation function that maps the pixel values to a nonlinear scale. This method can be effective in enhancing certain features of in an image, but may also introduce artifacts or noise due to in some cases. And we can take a formula also for this, that is g of x comma y is equal to f of x comma y minus minimum divided by maximum minus minimum into L, where g of x comma y is the output pixel value, f of x comma y is the input pixel value, minimum and maximum are the intensity values in the image, and L is the maximum intensity level in the output image. Nonlinear contrast stretching involves using a more complex transformation function that maps the pixel values to a nonlinear scale. This method can be more effective in enhancing certain features in an image. In conclusion, contrast stretching is a powerful technique for enhancing the visual quality of digital images by improving the contrast between the brightest and the darkest areas of the image. It is simple yet effective technique that can be used in a wide range of applications, including medical imaging, remote sensing, and digital photography. Let's move to the histogram equalization. Histogram equalization is another technique where we can enhance the image. That is, it is a popular image enhancement technique which is used in digital image processing to improve the contrast and brightness of an image. It is a spatial domain technique that operates on the pixel intensity values of an image. The goal of histogram equalization is to transform the pixel intensity values of an image so that the histogram of the image becomes approximately uniform. A uniform histogram indicates that all the pixel intensity levels in the image are equally represented. This transformation can be achieved by applying a histogram equalization function to the pixel intensity values of an image. This technique is effective in images with uneven lighting conditions, or where the distribution of pixel values is skewed towards a particular range. The histogram equalization function works by first computing the cumulative distribution function of the pixel intensity values of the image. The CDF represents the probability that a pixel in the image has an intensity level which is lesser than or equal to a certain value. This CDF is then used to map the pixel intensity values of the image to new intensity values. So this is a method to enhance the image, that is histogram equalization. Let's move to the next method, spatial filtering. Spatial filtering is also another method which is used in digital image processing to enhance or to modify an image by performing mathematical or operations on its pixel values. It involves applying a filter or a kernel to the image, which is a small matrix of numerical coefficients that defines the operation to be performed. Spatial filtering can be performed using two main types of filters. They are linear filters and nonlinear filters. Linear filters are based on the principle of convolution, which involves sliding the filter over the image and computing the weighted sum of the pixel values in the filter's neighborhood. The resulting output pixel value is then used to replace the corresponding input pixel value in the image. Then comes the nonlinear filters, on the other hand, are based on more complex mathematical operations that are not based on convolution. These filters are often used for more advanced image processing tasks such as edge detection, image segmentation, and object recognition. This is also a method to improve the image or to enhance the image. Let's move to the next method. Frequency domain filtering. Frequency domain filtering is a technique which is used in digital image processing to modify an image's frequency content by performing mathematical operations in the frequency domain. It involves transferring an image from the spatial domain, where the image is represented as an array of pixel values, to the frequency domain, where the image is represented as a combination of sine and cosine waves of different frequencies. Frequency domain filtering is a technique which is used to enhance an image by transforming it into the frequency domain using a Fourier transform. In the frequency domain, filters can be applied to remove unwanted frequencies or enhance specific frequencies. The most common transformation used in frequency domain filtering is the Fourier transform, which converts an image from the spatial domain to the frequency domain. Once an image is transformed to the frequency domain, it can be modified by applying a filter. These are the transformation we can see in all the four different methods enhancing the image. Thank you.